Right, so the way to solve this is we need to solve it in a certain sequence. Okay, so the sequence goes. Welcome to MirrorMatics. Today we'll be learning about the Chinese postman problem. The story goes, this postman will start from one post office, okay, will go through all the edges of a certain district, okay, and making sure that he passes through all the edges and yet goes back to the post office, right? This particular movement is actually called an Eulerian Circuit, okay, where it passes through all the edges, okay, and goes back to the same point that it started from, right? Okay, so the thing is, if you need to find or you need to make an Eulerian circuit, okay, the rule is every vertex needs to have an even degree. Okay, but usually your question will be set in such a way that there will be some vertices that has odd degree, right? So let's take a look at this particular example. Okay, the question says that this particular postman needs to start from A and end at A. That means A is the post office, right? Okay, so if you notice, let's count the degree of the vertex first. Okay, A is 2. Okay, so if it's even, we will know, we just take note of the one that's odd. So A is 2, B is 3. Take note. C is 1, 2, 3, 4. Fine. Okay. D is 2. Fine. E has 3. Take note. So B and E has 3. Okay. And then F has 1, 2, 3, 4. Degree of 4. Okay. So all the vertices are fine except for B and E. Right. So what you need to do now is that you need to find the shortest route from B to E. Right. So upon close inspection, you see if you were to go here, it will be like 6 and 8. We don't want that. Okay. And if you were to go here, 4 and 7, BC and then CE. Okay, 4 and 7 is 11, and that's a very small number, and that's the least actually. Okay, so what you do is there's actually a trick. Okay, after you found that's the shortest possible route, you actually create edges along that. So I'll draw it in dotted. Okay, indicate the width. Okay, CE indicates the way. Alright, so when you do that particular trick, what happens is, if we take a look at B, okay, including the dotted edge, okay, B will now have actually has an even degree. So 1, 2, 3, 4. Right? Similarly for E, okay, 1, 2, 3, 4. But what about C? Okay, C, we actually added one edge here and we added one more edge here, so we added 2. Okay, so for C, it is still even. 1, 2, 3, 4, 5, 6. Alright, so now every vertex is actually even. Okay, and with that we can actually form an Eulerian circuit. Okay, so what I'm going to do now is I will try to form the Eulerian circuit. Okay, but once I've gone through that particular edge, I will put a tick, okay, to indicate that it has been passed through. Okay, so let's try. We're going to start from A. Okay, so let's do alphabetical order so it makes it easier. So A to B, okay, and then B to C, I'll take the dotted one. Okay, C to D, done. Okay, D to E, E to F, done. Okay, so I'm not going to go back to A because there's still some edges that's not covered yet. Okay, so now we are A, B, C, D, E, F. Okay, then maybe from F, I'll go down to C. Okay, so I covered this one. Okay, and then you see this CE, right? Both the solid and the dotted has not been covered, so we can go take the dotted one first and then come back with the solid, or take the solid first and then come back with the dotted. It doesn't matter. Okay, so we're going to cover CE and then back to C. Okay, so this is covered and this is covered. Right, so now we are at C. We still haven't covered this edge yet. Okay, the CB here, okay, with a weight of 4. Okay, so now it's covered, we're going up. Okay, and now we can go back from B, right? We can go back to to F with a weight of 6, covered. And now we can go back to A. Okay, you'll notice that I've ticked all the edges. Okay, and I started from A and I end at A. Alright, so that's the root. A, B, C, D, E, F. And then I go down to C, E, C, B, F, A. Right? So that is how you solve the Chinese postman problem. Okay? Mirror Cikgu Hadi, that is how you study.